Outlier analysis and outlier detection. As the name indicates, we have seen in Unit 1 there are the outliers or noisy data available in the dataset. So we should focus on this outlier discovery as a part of the clustering. Outlier detection is also known as the anomaly detection. So it is the process of finding the data objects with behaviors that are very different from expectations. So they are not behaving normally. Such objects are called as outliers or anomalies. The outlier detection and clustering analysis are highly related tasks. In clustering, we find the majority of patterns in the dataset. So based upon the similarity, we have the groupings among them and we organize the data accordingly. But in the outlier detection, you tries to capture what are the exceptional cases which are deviated from the normal cases, which are deviated substantially from the other majority of patterns. So the problem in the outlier discovery is to find the top n outlier points which are deviated. The applications of outlier discovery are credit card fraud detection, telecom fraud detection, customer segmentation, medical analysis, public safety and security, industry damage detection, and image processing. So these are some of the applications of outlier discovery. So what is an outlier? So outlier is a data object that is deviated significantly from all the other objects, as it may be generated by the different mechanism than the normal objects have generated. So outliers are different from the noisy data. We cannot call this, but usually we refer these two terms interchangeably. But outliers are different from the noisy data, as the outliers may have been generated by the other mechanism that the normally used by the rest of the data. So outliers are interesting because they are suspected that not being generated by the same mechanism as the rest of the data. Therefore, in the outlier detection, it is very important to identify that why these outliers are detected, whether they are generated by the same mechanism or other mechanism as compared to the whole data set. And this is often achieved by making the various assumptions on the rest of the data. If the data object is satisfying this assumption, then that is not outlier. If it is not satisfying the assumption, then that is an outlier and it violates this assumption. So outlier detection is also related to novelty detection in evolving data sets. So we cannot always look at this outlier as an noisy part or not important. It may be used for the novelty detection. You can write down the algorithms, you can modify the algorithms by using this outlier detection. For example, you are monitoring a social media website, and in this side you have the new contents coming continuously. So you can analyze this new content continuously as this new content may be deviated from the usual content. So this kind of data can be analyzed to identify the novelty detection in these new topics, or it may be the new trend. So this is how you can have the outlier detection as an use for the novelty detection. Novel topics may initially These novel topics may appear as the outlier, but actually that are not the outliers. But to this extent, the novelty detections share some similarity in modeling and detection methods. So there is the critical difference between these two is that novelty detection, once new topics are confirmed, they are usually incorporated into the model of normal behavior. So, so that the follow-up of instances are not treated as outlier anymore. So whenever the new content is appearing, we can add it into our data set and we flag it as normal. Now the types of outliers. Next topic is types of outliers. So there are three types of outliers. First one is the global outlier, then contextual or conditional outlier, and collective outliers. First type is the global outlier. So we can see its name is the global. So if you are given a data object as global outlier, if it deviates significantly from the rest of the data set, we may call it as a point anomaly, and these global outliers are the simplest one. Most outlier detection methods are aimed at finding the global outliers. For example, you can see in this figure, all the data points are normally arranged in this space, but these two data points are far apart from all these data points. So I can use the distance measure or Euclidean distance, and clearly these data points are considered as outliers. So the object in this region are the outliers. To detect the global outliers, the critical issue is to find an appropriate measurement. So which measure we can use to identify this deviation. So we have seen the different methods to identify the similarity between the different data objects in the clustering. So we can have the different measures. So based upon the outlier detection method, they are partitioned into the different categories. So that will have the in the last two slides. Now, what are the applications of this global outliers? It may be used for intrusion detection in the computer networks. So if the communication behavior of a computer is very different from the normal pattern, for example, if the large number of packet is broadcast in a very short time, so this is not a normal case, so this may be considered as an outlier, global outlier, and we may have our computer as a victim of hacking. Second application is in trading transaction auditing systems. The transactions that do not follow the regulations are considered as the global outliers. The next type is the contextual outliers. The temperature today is 28 degrees Celsius. Normally, if we have 45 degrees Celsius in the month of December in Pune. So it is not the normal case. So in the month of December we may have the temperature below to 24 or 25 degrees Celsius or more than that. But if it is 45 degrees Celsius, then that will be the outlier. And this is based on the context, the environment. So whether or not today's temperature value is outlier, it depends on the context, the date, the location, and possibly the some other factors. So based upon the context, we may have the different situations and it may be considered as an outlier. The data object is contextual outlier. In a given data set, data object is a contextual outlier if it deviates significantly with respect to specific context of the object. So you can define the contextual outlier like this. It is also known as conditional outlier because it depends upon some conditions selected over the context. So in the contextual outlier, the context has to be specified as part of the problem definition. Generally in contextual outlier detection, the attributes of the data objects in question are divided into two groups. So we have the two types. Contextual attributes of the data object define the object's context. For example, in previous example, we have seen the date, the location matters. So these are the contextual attributes. Now behavioral attributes, these are the object's characteristics. And it can be used to identify whether the object is an outlier in the given context or not. For example, the temperature. So the behavioral attributes may be the temperature, humidity or pressure. And the third type of outlier is the collective outliers. So as the name, collective on the group. For example, we have the all electronics data, a supply chain manager of all electronics need to handle the thousands of orders and the shipments every day. If the shipment order is delayed, it is a normal case if one of the shipment is delayed. So it cannot be considered as an outlier because such kind of delays
हाँ
occur
हाँ
time to time.
ठीक है ठीक है झालं
Now, but if it happens that your 100 orders are delayed in a single day, so this may not be a normal case. So we can consider as a collective outlier. So given a data, a subset of data objects form a collective outlier if the object as a whole deviates significantly from the entire data set. So in this case, we are not considering the individual data object. So it cannot be individual data object cannot be outlier. For example, you can see in this figure, so all these data objects are equally distinct, so they are arranged properly. And if you see this group, so they are not equidistant or not having the proper distance among themselves, and this can be an collective outlier. So as a whole, this complete set of data objects can be considered as collective outlier because their density is much higher than the rest of the data. So every black object individually is not an outlier, but as a group it is considered as an outlier. Getting this? Any doubt? Yes, any doubt? Now, what are the challenges of outlier detection? First is the modeling the normal objects and the outliers effectively. So the outlier detection quality highly depends on the modeling of the normal objects and the outliers. So how we can model? So we should build a comprehensive model to identify the outliers, which are the normal data objects. So it is very challenging task. This is partly because it is hard to enumerate all possible normal behaviors. Normally, we cannot identify, we cannot specify all the normal behaviors. So, the border between data normality and abnormality is often not clear cut, but we have to model it in such a way. Consequently, while some outlier detection methods assign to each object in the input data set, so we can label them as normal or outlier. In other methods, you can assign each object a score for measuring outlierness. So we may consider as a 1 normal, 2 normal, 3 normal, 4, 5, 6. So up to 6 we are considering it as a normal data object. But if it is going beyond the 6, then we may consider as it is an outlier. So such kind of measurements we can have to mention the outlierness. The second challenge of this outlier detection is the application specific. So sometimes we may have some outliers based upon the application. So we can have the similarity measure or the distance measures for identifying whether this is an outlier or not, and it is a critical issue. So unfortunately such choices are often application dependent. So different applications may have the different criteria for the normal behavior, and based upon that we may have the different criteria for the outliers. For example, in clinical data analysis, so a small deviation may be important enough to justify an outlier. But in contrast, in marketing analysis, the objects are often subject to larger fluctuations, and consequently and subsequently a larger deviation is needed to justify an outlier. For example, a dose given to a patient is 5 ml, and if it is not followed consequent doses of the 5 ml, it may be given as a 6 ml or more than that for a small kid, then it is not bearable. It may get considered as an overdose, so it may be outlier for this case. So small deviations will not be acceptable. So this is an outlier for this clinical data. But it is not the same case of the marketing analysis. So in that case, you may have from 5 to 15 deviations to be allowed. So up to 15 it may not be considered as the outlier. So depends upon the different applications, the outlier, what are the outlier data points, it may be deviated. So outlier detections have dependency on the application types. The third type is having the challenge in handling the noise in the outlier detection. So outliers are different from the noise that we have seen already. It is also well known that the quality of the real data sets tend to be poor because of these outliers. So noise is unavoidably exists in the data collected in many applications. So noise may be present as deviation in the attribute values, or we may have some missing values in our data. So low data quality and the presence of the noise bridge a huge challenge in the outlier detection. So they can distort the data, blur the distinction between the normal objects and the outliers. So noise and the missing data may hide the outliers and reduce the effectiveness of the outlier detection. So this is the major challenge in handling this noisy data. So outliers may appear as disguised as a noisy point, and it may have the difficulties in the outlier detection. Fourth challenge is the understandability. In some application scenarios, the user may want to not only detect the outliers but understand why these data points are appearing as the outlier, why they are not normal, why they are out of the box. So why the detected objects are outliers. So to meet this understandability requirement, so outlier detection method has to provide some justifications for this detection. For example, a statistical method can be used to justify the degree to which an object may be considered as an outlier. So the likelihood may be identified, and based upon that we may classify this data object as an outlier. Whether the data object which is outlier is generated with the same mechanism that all the majority of data objects are generated, or it is not generated by the same mechanism, so that need to be considered in this case. So smaller the likelihood, more unlikely the object was generated by the same mechanism. So more likely the object is considered as an outlier. So understandability is very important to have this analysis of outliers. So these are the challenge for the outlier detection. Now the outlier discovery. So there are different statistical approaches that can be used for the outlier discovery. So based upon the data distribution. So we can see the data distribution. There is a curve of these data values are plotted on x-axis along with the probabilities. So the 2.5% data from this side and this curve side, these are not having the proper value, so it may be considered as an outlier, and the 95% of the area is having the normal data behavior. So such kind of data distribution, we can use the mean, median, mode or variance. Mean and variance as the distribution parameter. We may have the number of expected outliers. So we can put the certain constraints on this data distribution and to discover the outliers. The drawbacks are the most tests are for single attribute. In many cases, the data distribution may not be known.